Welcome everyone to the part 5 of Java day 14th session. So far we looked at the array list concept, linked list, vector, stack, priority queue, array queue. And what today we're going to look at is HashSet, LinkedHashSet, TreeSet, HashMap, LinkedHashMap, TreeMap. That's all about it. That's all about the collections framework. But before I start with the HashSet, LinkedHashSet and later on topics, let me talk about an important point regarding priority queue which we discussed in the last session. So if I look at this priority queue, well, yesterday I said that in priority queue it's mandatory that every user defined object that you create has to implement comparable interface. But I want to make a slight correction there, that it's not that every priority queue needs to implement comparable for its user defined type. You can also use an appropriate comparator object while creating the priority queue instead of comparable. So what really I'm talking about, let me explain you over here. So here, when I'm creating the priority queue for a user defined object country and I'm taking out things from it, it's going to throw an error saying comparable interface is not implemented in country if it is not implemented. If it is implemented, it's going to make use of that to find out which one is the minimum element in that priority queue, right? Now, what if you do not implement comparable interface there? You do not implement comparable interface. In that case, what's going to happen? Well, we looked at this yesterday also, that it's now going to throw an error, right? When you are going to run, it's going to complain you that country doesn't have the comparable interface. Right? That's what it is doing right now. Now what I'm saying is it's not really needed that country object has to be implementing comparable interface. It can also be done by making use of an appropriate comparator. For example, we make use of population comparator, and that's going to serve the purpose. So it's going to sort out things in priority queue based on this comparator. Populations, you can make use of population comparator, you can make use of name comparator, you can write any other comparator. So the idea is wherever you are making use of comparable interface, you can actually make use of comparator interface also if you haven't used the comparable interface. So that's a concept. I believe in the last session I showed you only demo with respect to comparable interface. I said that you have to implement comparable interface in the country object. Now I'm making a slight enhancement to that. What I'm saying is in priority queue you can make use of comparable interface with that specific user defined object like country over here I showed. And if you haven't implemented comparable interface there, then there's another way. The other way is you make use of an appropriate comparator while creating the priority queue. That's all about it. All right. So this was all about the priority queue. Now, as I said in the start, today we're going to start looking at HashSet and later topics. So let's very quickly start with HashSet. What is an HashSet? Guys, if we look at any real-time project, there we make heavy use of HashSet, HashMap, concepts like this. We make heavy use of all such concepts. Now what exactly are these Java collections, HashSet, HashMap and so on, which we're gonna look at later? Well, HashSet is a Java collection which is going to allow you to insert elements to it. Let's say you are inserting an element Ankush to it. The basic fundamental behind this collection is that it's not going to allow you to put duplicate elements. What that means? It means if you have put Ankush here, it's not going to allow you to put one more Ankush. If you put there, it's going to override this Ankush with this new one. That's all about it. But at any given point of time, it will not have two Ankush there. It will have only one Ankush. That two, which one is which you added in the end. All right. For example, here if you have added 10, 20, 30, and then 40, and then you have added 20, then it's not what it's going to do. It's going to modify this 20 with this value. What you have just added means at any given point of time, you can add only one kind of item. If you try to add duplicate of any existing item, whatever is present in that collection, then that is not allowed. In other words, what an HashSet does behind the scenes, it's going to override the existing one with that new value. That's all about it. This is how an HashSet works. So basically it's a set of unique items. It's going to allow you to include unique items in your Java collection. So that's what is an HashSet all about. This is how we write an HashSet non-primitive type. HashSet is equal to new HashSet non-primitive type. There's nothing specific. The way we have done things, the way we have used other Java collections, same way HashSet also works. Nothing special about it. As I said, that it's just about keeping all unique items. That's all about it. So it means it's not going to allow duplicate elements, and it doesn't maintain any order. So here is, let's suppose your HashSet, and you have here included, let's say 2, 10, 5, 1, 200. If you are going to add elements in this order, first 2, then 10, then 5, then 1, then 200, it's going to just keep all these elements, and it's going to take out all duplicates from it. And one more important point is it's not going to store these elements in any specific order. It's not exactly going to do. Maybe it's going to keep 2 here, and then it's going to keep 200 here, and then it's going to keep 10 here, then 5. So it's not going to keep things in any specific order. So you have added all the elements in the order 2, then 10, then 5, but it's not going to store elements in the same order. So that's what this means, doesn't maintain any order. Now, what is the advantage of using an HashSet? The advantage of using an HashSet is so good. Let me explain you that. Well, that's the reason why we make use of HashSet and other later topics that I'm going to cover heavily in real-time projects. So let's say this is a HashSet. Here you have stored Ankush, here you have stored Gaurav, here you have stored Gontu, here you have stored apple, orange, say banana. Alright, now let's say this is your HashMap. Now one thing is clear, that it's not going to allow you to include duplicates. That's one thing. But what about this advantage? Let's talk about that. Let's say here you have a requirement that after keeping all these elements in the HashSet, you want to basically just check whether some element exists in that HashSet or not. For example, here you want to make a check, hey, whether apple is present in the HashSet or not. This is what you want to check. Now, how to do that? You would simply make a call to one of its functions, HashSet function contains, HashSet.contains, and you will pass apple to that, and it's going to check whether apple exists in this or not. But the best part of this check operation is, in order to know where apple might be stored in this HashSet, it's not going to search like this. It's going to compare apple with Ankush, no. Apple with Gaurav, no. Gontu with apple, no. Then apple with apple, yes. Then yes, apple is present. So it's not going to actually do search operation like this. What it's going to do, as soon as JDK is going to execute HashSet contains method, and there you are going to pass Apple to that. What it's going to do behind the scenes, it will compute the position where Apple might be present in this HashSet. So it's going to tell, hey Apple, if Apple is present in HashSet, then that must be present at say 0, 1, 2, 3. Then that must be present at third location. Are you getting my point? So behind the scenes, what happens when system executes this function? It simply computes, if Apple is present in this HashSet, then that Apple must be present at third position. So let's go and check third position. If we find Apple, then it's great. We'll return true for this, that Apple is present. And if at third position we do not find Apple, it means Apple is not present. So this property of HashSet, whenever you want to search anything, it performs that search instantly. That makes it so useful. That makes it very, very fast, because its search operation is very fast. It doesn't perform search to search any element. It just computes its position directly, and after you get the position, you simply go to that position to check whether Apple is present or not. This makes it very fast and so handy and so useful in real-time projects. Okay, now let me give you an example in other Java collections. Say in linked list, say this is a linked list, right? One element is pointing to another one, then another element is pointing to another one, then another element is pointing to another one, and then last element is pointing to null. This is what we learned in case of linked list. And yes, this element is pointing to previous element, right? And this is pointing to null, right? This is doubly linked list. What we learned earlier. Now here, if you have stored Ankush here, then Gaurav here, then gone to here, if I ask you, hey, search gone to, then how you are going to perform the search operation? Well, you're going to go to the first element. You're going to compare, whatever you're searching for with this. If you do not find, then you go to the next element, then you go to the next element. So you have to traverse through the linked list to know whether that element exists in it or not. That's so time taken, right? Let's say there are 1 billion elements in it, and the element which you are searching for is actually present at 1 billionth index. Then you have to traverse through all the elements before that 1 billionth element to understand whether that element exists there or not. Now here, see how much advantage you get. Whenever you want to search, it's going to give you direct index, it's going to compute its index directly, and you go there. If element is present there, you say it's present. If element is not present, you say it's not present. It's so handy, correct? So that's how it works. Now in case of a normal array also, if we look, this is an array. Let's say in the array you have stored Ankush at 0th index, Gaurav at 2nd index, then gone to, and then Apple, and then banana, and so on. Let's say this is your array, 0, 1, 2, 3, 4, 5, 6. Now here if I ask you, hey, can you please check whether Apple is present in the array or not? Now how you are going to check, how computer is going to check? Whether it's going to run a for loop, and it's going to compare Apple with first element. If it's not present, then it's going to go to second element. Till the time it's going to get Apple, it's going to compare every element with Apple. That's how an array works. So here also it's time taking approach when you're searching for any element in an array. Even if you're searching for any element in the linked list, this is basically, I'm talking about an array list. Alright, this is an array list. So if you're searching for any element in case of an array list, that's so time taking. If you're searching for any element in the linked list, that's so time taking. But if you're searching for any element in HashSet, then that's not time taking. That's going to give you result instantaneously. If something is present, it's going to say yes, present. If something is not present, it's going to say no, it's not present. So this is HashSet. Before I show you how to make use of an HashSet programmatically, let me talk about an important point. That in case of an HashSet, when you make use of a user defined object like country, there you have to override two methods in it, HashCode and equal method. Now what does that mean? We're gonna look at later. Let's talk about things till this level first. Let's see demo till this level, and then let's see what exactly I mean by HashCode and equal methods to be overridden in a user defined type like country. So what exactly that means, let's see that. But before that, let us see what is in HashSet programmatically. Alright, so we have so far looked at lists, queues, and now we are going to look at the third category, and that is set. Okay, so here let me create one more package. Org.contour series dot collections dot sets. Alright, now here in this package, let me copy the demo from here. This is HashSet. So copy it over here. After copying it, I just got to change the package name. I'll set it to sets. Cool, everything is perfect. I have to import all required things. Cool, so everything is done here. Yeah, so this we changed initially. That's the reason it was giving red color in all these files when I was talking about priority queue. Alright, so I've reversed that. Okay, let's move to HashSet. Now what is HashSet? HashSet is just like any other Java collection. The only advantage what it provides is it's going to contain only unique elements in it first, and second, if you are going to call its contains function, then it's going to give you a result instantaneously. That's how it works. Okay, now this is the way how you create a HashSet object. If you want to create an HashSet, if you want to create a HashSet for string object, for string type, then this is the way. To add elements to it, you go on doing that, and then you run an iterator over that. It's going to display all the elements, but please make sure, please understand that whenever you run an iterator, it's not going to give you results in any specific order. No order is going to be maintained anywhere. Okay, its will whether it displays Ankush first or Gontu first or series first or Gaurav. So it may display any number, any object at any position. So this is how the iterator works for it. If you want to remove any element, well, here also same property is going to be applicable. In order to remove an element with the name gone to, it's going to search for that element first. Now as you understand that HashSet people make use of why, because its search operation is so fast. So it's going to search gone to instantaneously, and once it finds that, it's going to remove that, and once it removes gone to from that, no shifting is required, nothing is required, because no work is required to find out or to delete something. It's very fast. So remove operation is very fast, contains operation is so fast in case of an HashSet. Alright, so this is how it works in case of strings. Now here, if by any chance I try to add Gaurav here, what's going to happen behind the scenes? Well, it's going to add Ankush to HashSet, then Gaurav to HashSet, and then it's going to find Gaurav again. When it finds any element which we are adding in it, which is a duplicate element, means already an object, and already same object is present there. In that case, what it's going to do, it's going to simply override this object with this latest object. That's what it does. So no way it's going to allow you to duplicate. So here you have added 1 2 3 4 5 elements, but how many elements it's going to add in the, it's going to allow you to add in the end? 4 elements, because because these two elements are same for it, so it's going to keep only one copy of Gaurav. not 2 copies. So overall, how many elements it's going to store? It's going to store only 4 elements. So that's what it's going to display over here. If you want to create an hash set for integers, well, this is the procedure. You create an hash set for the integer, you go on adding integer elements to it, and then you iterate through that. Well, no specific order is going to be maintained. That's the property of hash set. If you want to remove, it's going to remove that element. If you want to check whether some element is present there or not, you can make use of contains. As I said, people make use of hash set only for the reasons that it's going to allow you to enter only unique elements in it first, and second, search operation is very fast, delete operation is very fast. Very fast means instantaneous. No checking, no comparison is required for that. Okay, now what about this country? If you want to make use of country user defined object with hash set, how it works? So it's going to store all countries objects like this, and definitely when you iterate through, it's going to display country objects not in any specific order. So far it's good. But what about this? When you want to remove an element which is having which is basically a country object having a value India and 20. Okay, now tell me on what basis it's going to identify whether this object is already present there or not. Maybe the criteria for you to compare two country objects is that you want both objects to be equal when their population is same, or maybe when their names are same. So let's suppose here I write Russia, right? Now it's your criteria how you want things to be compared. When you want to remove this object, well, looking at this, definitely there is no object present in the hash set, right? It's a new object, looks like. But maybe you want when you say remove this, you don't want objects to be compared based on their names. You want objects to be compared based on the population criteria. Means if it's going to find out any object having a value 20, then that object should be removed. This is what you mean here. So here, whenever you want to check, whenever you want to perform the remove operation on the hash set, you pass an object whichever you want to remove. Now you may mean that if you find any object here where name is equal to this and population is equal to this, it's only then you remove that. First is that criteria. Second criteria is you want it to remove an element if population matches with any existing record, or maybe you want it to remove any existing record if its name matches with that. So it's all your choice, and that choice you have to tell how. You have to tell by making use of something called as equal method in the country object. So what you have to do, you have to go to the country object, and there you have to write here something called as public int equal object that override return p and return p. Alright, so you have to implement equals method. Alright, now one thing you have to understand, guys, I haven't talked about that very important thing so far with you guys, and that important thing is every class, whatever you write, whatever is provided by JDK, every class, whatever you write, whatever is present in Java is actually by default inherited out of the object class. So what does that mean? Let's say you are writing a class ABC, or maybe calculator, or maybe tiger, or maybe animal. Now by default every class is inherited out of object class. So you do not write tiger extends object. You never write this. But by default it is considered like this only. So you write only tiger, and that is all, that is considered as a class which is inherited out of object class. So every class in Java that you write or is provided by JDK is actually inherited out of object class by default. That you cannot see extends object, but it's considered always like that. And in object class there are so many methods. HashCode is one method which is present in object class. Equals is another method which is present in object class, and likewise there are so many methods available in object class. Now idea is, whenever you use HashSet, that time whenever you pass an object there, whenever you pass any object there, say country object, whenever you pass this object there, you have to tell Java that on what basis it's going to search this element in it. You have to tell that criteria. So you have to tell either it should be considering both to compare, or only one, or only second. So you have to tell. Now in order for you to be telling JDK that based on this criteria, you go on comparing this object with the existing one, and then whenever you find that, simply remove that. So this is what you basically want to tell. Now in order to do that, there is a compulsion in JDK that in your country class, in that user defined class, you have to implement the equals method. You have to override the equals method. Now country class is inherited out of object class. Well, you cannot see that extends object. As I explained you here, every class is by default inherited out of an object class. You cannot see that extends object anywhere, but it's considered always like that. And what's mandatory? When you are making use of a hash set, that time when you remove any element, or when you give it a command, say contains this object, that time JDK needs to know on what basis, on what criteria it needs to compare this element with the existing elements, whether it should be comparing the elements both on both the properties, or only one property which is this one, or only this property which is this one. So JDK makes it mandatory that you have to override the method equals equals method which is present in object class, in that user defined class. And what you are going to write there, well, I'm going to show you. All right, so you can write that method fully yourself, and this is the syntax for that. So this is going to return a boolean value. All right, so actually this is not n, this is boolean. Let me write there boolean flag equals to by default false, and same is what I'm going to return from here. Now here in this equal method, so this method equals is present in the object class, which is definitely inherited in the country class, and JDK says if you want to use HashSet, well, if you want to make use of contains and remove functions of it where it needs to search an element in the existing set of elements in the hash set, then it needs to know the criteria, how it should compare that very element what you want to search against what is already present there, and that criteria you have to tell using equals method. So this equals method is present in object class. JDK says that you have to override that method here, and you know what override means, right? So this is one of the uses of override concept. So one method is present in its superclass, something is written there. Now you're overriding that. Now you're overriding that with the new functionality. So whenever equals method is going to be called, object class equals method is not going to be called. This class equals method is going to be called. Now what criteria I want, I can write over here. So I want, whenever you are searching, whenever you want to remove this element, I want this to be compared based on only population and not name. So it means if it's going to find, if JDK is going to find any record here whose population is 20, well, that is a criteria. That is a criteria for search operation, and it's simply going to remove that complete object. Means it's going to remove this. And here I can choose whatever criteria I want. So let me first write that criteria. Well, what's going to happen whenever you make a call to the remove function, behind the scenes what it does, it makes a call to the equals function. So what it does, it makes a call to the equal function on that object. Okay, on that very object it does that, and it passes that object to that also, right? So here what you basically are going to write is this. So well, this is something that we have been doing in compare to also, right? Comparable interface, you remember? So what we were writing there, let me show. So we were writing there. So same thing I'm going to write here, nothing much, no difference at all. Same thing I'm going to write here also, same criteria. Let me write it and show you how this works. Now whatever object it sends here, you're gonna typecast that to the country object, cn equals to country. Guys, if you're not able to keep up the pace, keep going. I'm requesting you, don't stop. Just finish up this session and come for one-on-one conversation with me. We have reached to the end of Java collections. Now this is what I'm talking about. May appear a little tricky topic, may appear something which is confusing you, or you may be not so comfortable with this, but keep going guys, just keep going, don't stop. And I'm gonna make you comfortable when you are going to appear for one-on-one conversation. Let me tell you an interesting point. If you have been understanding all through so nicely, then this is the last topic in Java collections. Even if you are a bit uncomfortable here, it's okay. Even if you do not get 100% of things, it's okay. But just keep up the pace, just maintain the pace. And if you're not comfortable right now, I'm going to make you comfortable anyways in your one-on-one conversation. The way you understand, the way you want to understand about the things. And slowly and gradually, I'm going to make you perfect. But only thing that I want from you is you have to just go on. You should not be stopping anywhere. Okay, so keep going guys. All right, so you have to typecast this to cn, and this is this object. So whichever object is going to make a call to, so that's going to be here. So here I want it to be comparing based on this. So what I'm going to do, I'm going to simply say anywhere if you find so what I'm saying here, so when you are comparing, when JDK is comparing this object, this object, right, with any of the existing objects, right, what you do, you compare its population with that population, existing objects population, and if you find both are matching, then you return true. and if it has returned true, it means whatever you're searching for, actually it has found there, and it's going to simply remove that. If you are making call to remove function, if you are just making call to contains function, then it's going to simply tell you whether this object is present there or not, simply by making a call to equals function all the time. So now that we have overridden the equals function, and this is how it works. If you don't want to include only the population criteria, then what you do, you check for other criterias also, like if population equals to cn dot population and this dot name dot equals cn dot name. Yeah, maybe you want to use two criteria, so till the time it's going to get an object where it's going to match both, where it's able to match both the property, it's not going to stop. So anywhere it's going to find out that name and population both are matching, it means it has found out that object, otherwise not, according to this criteria, because it's only in that case it's going to return true, and true means yes, we have found out that element. Otherwise flag values as false means it hasn't found that yet. Make sense? So it's your choice, you choose only population or only name like this, or both like this ampersand, or maybe or. So if anyone matches, you want to instruct JDK to understand that object is equal to that existing one. All right, so this is how, guys, this whole equals method works. But one important point what you have to understand is, when JDK says that to understand equality, how it's going to compare the object what you are searching for against what it has already existing in that hash set, you have to tell equals method. You have to write equals method. That's going to present the criteria. But there is one important thing what JDK says. JDK says whenever you are giving us instructions, hey developer, whenever you are giving us instructions to compare things, to compare objects using its equals method, then it's mandatory that there you have to implement HashCode method also. Now what is this HashCode method? Well, I'm simply going to write their HashCode method right now. I'm not going to explain you. I'm going to explain you this later on. Okay. For now, what you have to understand is, if you are going to perform search operation on a hash set, then it's mandatory for you to write equals method, which is going to basically tell JDK on what criteria, on what basis it has to compare that object with all existing objects. And for equals method to work correctly, you have to also override the HashCode method. Okay, now what is HashCode method and what exactly I'm going to write there, how it works behind the scenes, and why Java says for equals you have to write HashCode and this and that, all of these things we are going to talk about later. Okay, for now what you have to understand is you have to write equals method, and because JDK has said okay, for equals you have to write HashCode, you have to implement HashCode method also, which is also which is also a method in the object class. Then let's do that, but we'll understand this HashCode part later on. Okay, so here for this equals method, for this equal method to be able to work properly, you have to override one more method of the object class, and that's known with the name HashCode. So let's very quickly write that. Public int HashCode. Let's say there's a int 2. I'm going to return 2. Cool. and because this I'm overriding, this method is present in the object class, so I'm overriding that. So that's the reason I'm writing this @override. This is just telling that this method doesn't belong to country. This method is actually belongs to its superclass, and that method we are simply overriding here. That's what it means. Now what I've written here, int a equals to 2 and returns 2. Well, it's going to always return 2. So what's the meaning of this and this and that? Well, you for now simply ignore this method. Okay, I've written here or I haven't written here, just simply ignore that fact. Concentrate on this equals method. So whenever you are going to make a call to remove function or contains function, it's going to actually use equals method to understand how that equality operation has to be performed, how it's going to check whether the object which you are searching for is present in the existing set of elements or not, using equals method. And for this equals method to be able to work properly, you have to override HashCode. Now what is this? We're gonna talk about this later on. Once you are able to understand, once you are able to digest equals method, it's only then I can talk about HashCode method. Okay, so try to digest this concept fully, and whatever things you will not be able to digest, I'm going to talk about all that later in the one-on-one conversation. All right, so now that we have written equals in HashCode, we have defined the criteria. Now according to this criteria, whatever object you are searching for, that object's population and name both should match. It's only then you can say that object is present or not, otherwise no. So here, that's the reason I have written in the comments, will it remove country object with a value India and 20 ? Well, it can remove only and only if HashCode and equals method are overridden country. So this is going to perform remove operation. This is going to perform contains operation only and only when you're going to put the criteria on how the objects has to be compared, that is equals method. If you do not specify the equals method, well, this is not going to work. Always it's going to say, even if objects have matching values, it's going to say there's no matching object found, so I'm not removing this. When you say contains, this, if you haven't implemented equals, if you haven't overridden equals and HashCode method, and you are performing this contains with this object, it's going to return that such an object is not present there. It needs equals method to understand on what criteria it has to compare. It's only going to work in that case if it finds equals method. And for equals method to be able to work properly, HashCode method has to be there. Now it's enough. So before I show you this concept running the whole hash set, let me tell you an important point. I said for a user defined type, whenever you are removing or containing, equals method and HashCode methods have to be implemented in that user defined type. Well, what about string hash set? Here I'm removing and contains. Here I'm saying it's going to work properly. Why it's going to work properly? Because in this string class, HashCode and equals method are already implemented. So string object has been given to us by JDK, and it has already implemented equals and HashCode method in it. That's the reason these are working. Same is the case with integer class. So if you are using HashSet for a user for JDK defined type integer, then these are going to work. Why? Because equals and HashCode method have already been implemented there. That's the reason these are working properly. Now when you are writing a type on your own like country, then it's your job to make sure that you are writing equals and HashCode method there. Now one important point before I show you this concept working. Guys, in case of HashSet, I'm saying to compare two objects, it uses HashCode and equals method. Okay, this is not equal, this is equals. Let me correct that. Okay. Now, when you are making use of HashSet, system is going to expect, JDK is going to expect that your country class should have HashCode and equals method written there. But in any of the other things, what we studied, array dequeue, priority queue, linked list, stack, vector, array list. So whatever we have studied so far means till this point, whatever we have studied, to compare two objects, what it was needing? It was needing comparable interface or comparator interface, right? So to compare two objects till this point, it was using comparable interface or comparator interface. But for HashSet, it doesn't use comparable interface. It doesn't use comparator interface. What it uses is equals method. And for equals method to be able to work properly, you have to implement HashCode method also. So HashSet compares two objects equality based on equals method and HashCode method, but array list, linked list, vector, stack, priority queue and array dequeue compares two objects by using either the comparable interface, using the compare to method what you would be implementing that user defined type, or using the comparator. Okay, so in case of comparator, you know which method it uses, compare method. All right, so compare to and compare methods are used till this point, which are being provided by comparable and comparator interface. But for HashSet, it doesn't make use of these two things. It uses equals. So this is a quick shortcut I'm telling you. So this is all enough, guys. Let me show you this concept running. See, everything has worked so fine. So here I have written Ankush, Gaurav gone to series. When I displayed, how many elements it displayed? Series Gaurav, Ankush, gone to. I added Gaurav twice, but it didn't display Gaurav twice. It means it eliminated that duplicate element. And if you look at the order, no specific order is maintained here. It has displayed things in some order what it felt like using, but not this order. So no specific order is maintained. When you here removed element gone to, so after this line, if you are going to use this iterator, it's not going to show you gone to. And this contains method returns boolean, means whenever you use this method, it's going to return true. If series is series, it's going to find out. If it's not going to find out, it's going to return false. And how these two methods are able to work? Because string type has implemented equals and HashCode methods. Same is the case with integers. See, it has displayed all the elements, but definitely not in the order you have written. And then it has removed the element 20. If you want to use iterator after this, it's going to display all the elements but this 20, because it would have removed that element because of this statement. And when you use contains, it's going to simply return true or false. True in case it finds this here, false in case it doesn't find. An important point what I have already conveyed you, in case of the HashSet, this operation remove and contains is like very fast, very fast. No such operation, like no comparisons. Whenever you are looking for any object, it's going to tell, some logic is there which is going to tell, hey, if this object is present, then that object must be present at this particular index. So go and check. If that object is present, it means it is present. If that object is not present, it means that object is not present there. So instantaneously it's going to give you the results. Same is the case is with the HashSet. So here we added all these elements and then it displayed all, but not in any specific order. So no specific order. So here you may be seeing that order, but it doesn't use any specific order to display all the elements. So maybe when you are going to add 1000 or 2000 elements to this country objects to it, its result, whenever you use iterator, you are going to get different order than what you have added. So here it's a chance that it's displaying things in the same order, but it doesn't. So no specific order is guaranteed. When you make use of remove function, because here we have written in the country class that remove function has to be comparing population with population and name with name. So unless and until it's going to find name matched with any object, and for that object population has to be matched, it's not going to say that object is present. So because Russia and 20 are nowhere present, so it's going to say it cannot remove that object because that object is not present. Well, for this it's going to check the object, and it's going to find out whether there's an object with India and value 20 which it is looking for. So it's going to simply say true for this. And if I here change this to say this one, what's going to happen? In that case, it's not going to match name with existing one. It's going to match only the population, because here I've specified population in this boolean. So what it's going to do is going to simply match this with the population. Wherever it's going to find 20, it's going to say, hey, I've got the object. So it's going to return true. So that's how this works. So here let's use both. So this is all about the HashSet concept. Now equals and HashCode method is very important, guys. Very, very important. What you have understood is, in order to for an HashSet to work properly for remove and contains kind of functions, you have to write the equals method, because using equals only it can know what is your criteria to compare objects. Yeah, so that's what you tell. But for equals to work, HashCode method has to be implemented. Now what exactly is this HashCode method? I'm going to talk about this later on. Once I understand that you are able to digest HashSet and other collections properly, then the next thing what I'm going to do is to explain you fully what is HashCode. Now before I explain you HashCode, let me tell you an important point, that HashCode is the most important topic and the easiest topic. It's just that I'm waiting till the time you are going to digest all that whatever we have learned, and immediately after that I'm going to talk about HashCode. Well, I'm going to finish up that in not more than 7 to 8 minutes. So this is that small, but I cannot talk about HashCode right now, because I feel if I talk about that, then definitely you will get confused. So this is all about HashSet Advantage, because it's very fast. Remove and contains methods are very fast. That's what I've said here, and it's able to do that without comparing the element what you are searching for with the existing elements, using a technique known as hashing. Now this hashing technique actually works on the principle of HashCode itself. Okay, so hashing technique, it uses to give you direct result, to remove any specific object. It doesn't searches, it directly goes to that index. If object is present there, it says yes, it is present. If it is not present there, it says directly that it's not present, without going to other elements, without comparing whatever you are searching for with all the elements. It's going to directly tell you the result. Now that works on hashing principle, and this hashing principle actually is related to HashCode. So once I find out that you are comfortable with all of the things, you are able to digest all the concepts, then I'm going to talk about hashing technique, in other words HashCode method. So this hashing technique has to do with something with HashCode. So that is all about this special case. Now an important point what I'm going to talk about, well, I'm not going to explain you that. I'm just going to talk about behind the scenes. HashSet internally makes use of arrays as well as linked lists to store things. So it uses both to store things. Array lists and other array lists see, let me show you. Array list uses arrays behind the scenes. Linked list uses a doubly linked list behind the scenes. Vector uses array. Stack uses array. Alright. And this priority queue also makes use of an array behind the scenes. Array queue also makes use of an array behind the scenes. And HashSet makes use of an array and a linked list together. Okay, so that's a important thing that you have learned. Now how it uses, well, that I cannot explain you today, because if I explain you that, you will get confused. Maybe some other day I'm going to explain you all that. Once maybe when we are talking about hashing technique, or in other words HashCode method, same day I will tell you how a hash set store things using arrays and linked list concept behind the scenes. But this is what you have understood fully, right? So let's proceed further, guys. Now let's talk about something called as HashMap. This HashMap is a very important Java collection. I haven't worked on any real-time Java project which doesn't make use of HashMap. So you work in any Java project, that's actually going to be making use of HashMap for sure. And you know what, it's very unlikely that some project is not actually making use of HashMap. Every project makes use of an HashMap, and it's very easy also. Let's talk about what exactly is it. Well, HashMap will allow you to store key value pairs in it. Now what does key value pair means? Key value pair means whenever you want to store, say you want to store Ankush at a key 1, Gaurav on a key 2, say Gontu on a key 10, series on a key 12. Now what does it mean? It means you have stored key value pairs in it. You have stored one key value pair, 1 as key and value as Ankush, 2 as a key, value as Gaurav, 10 as a key, value as Gontu, and 12 as a key, value as series. So the idea is, once you have stored these key value pairs in it, at any given point of time you can request this Java collection to retrieve you what value is stored against a specific key. What it means, you will make a call to its get method, hashmap.get, and you'd specify here the key. Say for example you want to retrieve what is stored at the key 10, then it's going to get you the object gone to. If you write here 12, then it's going to get you an object which is stored against the key 12. The idea is it's going to store all these key value pairs like this in the memory, not in any specific order, but randomly it's going to store key value. So you'll always be able to search for any key here, and depending on what key you are searching for, it's going to get you the corresponding object. Now this key here, I said you can use key using integer, the way I said. So you can make use of an integer as a key, integer object as a key, or you can make use of a string object also as a key. Maybe you have stored a, Ankush against a, or maybe again Ankush against a key AB, Gaurav against a key CD, Gontu against a key EF, and series against a key GH, right? Now when you are searching for this, you would say, hey, please get me the value what is stored against AB key. So here what I mean is, key can be an integer or key can be a string, and this key can also be an object. For example, country object. Let me explain you that. So here what I mean is, key can be an integer, key can be a string, and key can be a country object. Key can be a user defined object. So here let me write key and value. All right, let's say Ankush, Gaurav, Gontu, series. We have to store 4 values against a key 1, 10, 14, and 12, right? So I've used here integer as a key to store these values. I can make use of a string object to be used as a key. So I will choose AB, C, D, D, E, F, G, or say name. I would write something, I would use some string as a key, not necessarily ABCD. I can use my name. I've stored, say, against India I'm storing Ankush, against US I'm storing Gaurav. So likewise, I can make use of a string object to be used as a key, and also I can make use of user defined object to be used as a key, like country objects. I would say country India 10 as a key, which is going to correspond to Ankush. Likewise, I can make use of any other country object, say America 1000, right? This is what we have been using, country object. So I can make use of country object as a key. Now the important point what you have to understand in case of an hash map is, people make use of hash map. Why? Because they really want to store key value pairs in it. And the advantage what hash map gives is, it allows you to retrieve any value stored against any key very, very fast. So what does it mean? It's going to contain key value pairs, right? It's going to contain key value pairs. And when you request it to, whenever you make a call to its get method, map.get, you would specify here the key. That could be an integer, that could be a string, or that could be user defined object, because you can make use of a key. You can use anything as a key, any Java object as a key. Now whatever key you are going to refer here, what it's going to do, it's going to, as soon as it finds you using get method, behind the scenes what JDK is going to do, it's going to see, hey, this key if is present in this container, then that must be present at the index 4 or at the index 6 or at any other index. So looking at the object itself, JDK behind the scenes is automatically going to tell, if this key somewhere is present in this Java collection, then that must be present at this specific index. So go and check whether that key exists there or not. If that key exists, then corresponding to that, whatever object is stored, just return that. And if that key is not present, in that case, just return that key is not a valid key, what you are searching for. Now, if you look at the way HashMap works, it's exactly the way HashSet works. In HashSet, what we basically store is objects. And when you search for any object, it gives you the index of that object automatically. Now you go to that index. If that object is present there, you say it is present. If that is not present, you say it is not present. And what is HashMap? It also does the same thing. The only thing is here, it allows you to store objects, and the way it helps you to retrieve any object instantaneously in the HashSet, same way, exactly same way, using the same hashing technique, it's going to get you the key in the hash map. So the idea is very clear. In the HashSet, you store objects, and there is nothing that you store against those objects. But in HashMap, you store objects, and against each object you store a value. That could be an object. That's what is HashMap. So HashMap, if you take out the value portion from that, right? HashMap is nothing but key value pairs what you store. If you take out value, if you are only storing keys, means if you are only storing objects, then that becomes HashSet. So like HashSet doesn't allow you to store duplicate objects in it. So here HashMap is not going to allow you to store duplicate keys in it. So if you notice, HashMap exactly works the way HashSet works. The only difference between the two lies in the fact that in case of HashMap, with every object that you store a value against that, so that when you are searching for any object, any key, then against that, whatever object or value is stored, you will be able to retrieve that, right? So this is nothing but a hash map. Now, why hash map? We have understood, because we want to store key value pairs in the applications, and once we have so many key value pairs filled up in the hash map, like billion or trillion, whenever we want to look for the value what is stored against any specific key, any specific object, then that has to be done very fast, way. And that's what HashMap does allow. So whenever you use get, some key you specify, it's going to give you, that object instantaneously without searching for that inside that HashMap. It's not going to compare that key with any of the keys. It's going to give you directly an index where actually you have to go and search for that same key. If it is there, it means it is there. If it is not there, it means it is not there. So that it does using a technique known as hashing. Same thing what I showed here. HashSet stores objects using the technique hashing and using HashCode and equal method, to understand how it has to compare those objects. And here it does the same thing for the keys that we store, and definitely object whatever we store is against that. This thing is key and this thing is the object what you store against that. So here also you can choose a key as any non-primitive type, object as any non-primitive type what you are going to store against that. It is not going to allow you to enter duplicate keys, and it also doesn't going to maintain the order of the keys what you are going to store. So if you have stored 1 billion keys and with every key you have stored some object, well, it's not going to give you those keys in the order you have inserted things in the HashMap. Whenever you're going to run an iterator, it's going to give you all those keys and the values what you have stored against them in no specific order. So it doesn't maintain any order. Well, allows it, it uses the technique hashing, and using that technique it allows random access. That's what I explained. Whenever you want to run a get operation on that, it's going to give you the results, whatever value stored against that with so fast speed. And that it does using hashing techniques, means it does it using HashCode method, which I'm going to explain you later. As I said, in case of HashSet, hashing I have to explain. Hashing in other words means HashCode method. So I have to explain that. So that's something I have to explain, HashCode method. So what thing you have to understand is HashMap and HashSet are same. The only difference is in HashSet we only store keys, but in HashMap with every key we store some value. That is what you have to understand. And in case of a user defined key, what you are storing, you have to make sure that you are using HashCode and equal method. You have to implement HashCode and equal method the way you did in case of HashSet. Now, if you haven't understood everything what I spoke about just now, it's okay. These concepts are not so easy to grab instantaneously, to grab very easily. Give some time to yourself. Right after this session, come for one-on-one conversation with me, and I'm gonna make sure that you will be knowing things and you will be much more comfortable after talking to me in the one-on-one conversations. All right, so let's very quickly have a look at the demo for the HashMap. Well, before I show you a demo, let me repeat once again the difference between HashSet and HashMap. In HashSet, we store only keys. Only keys are being stored. These are called as keys. Okay, and remove and get or contains operations are like remove and contains operations are very fast. Search operations are very fast because it uses hashing technique to know where that object is stored, to know where that key is stored. And in HashMap, it's about storing keys, and with each key you are storing value. Okay, it also does use hashing technique, means HashCode method. Cool. Now, whenever I'm showing you HashMap, think it from the perspective of HashSet itself, that everything is going to remain same except the point that with every key we are going to store a value also. That's it, and everything else is going to remain the same. So here is the HashSet demo. Let me copy from here, HashMap demo. So here is the HashMap demo. Let me copy it. All right. So here we talked about lists, we talked about queues, we talked about sets. Now we are talking about one more thing called as maps. So we are going to create one more category over here. Org dot gone to series dot collections dot maps. So HashMap comes under category maps, but it's working the same like sets. The only difference is in sets we store keys, but here with every key we store some value also. If you look at it, it's going to be exactly same the way sets or HashSet works. Cool, everything is perfect. Now let's try to understand. This is the way to write a hash map. See the syntax, hash map, and then you store the primitive, the type which you want to use for the key, comma, what objects you want to store against that key, right? So this is what you have done over here. I want to make use of key. I want to make use of string as a key, and to that string key I want to store a string object. So what I'm doing here in this map one, I'm calling it put method. I'm storing a key. So what I'm doing, I'm storing a key Ankush, and against Ankush I'm storing a string object. Its value is hi, I am Apple. Then I'm storing second key object, string object Gaurav, and to that against that I'm storing this. Then gone to, against that I'm storing banana, series, against that I'm storing line. Now if I iterate through this, this is the way to iterate through it. In HashSet, what was the way? Same way. You are using iterator. You were getting string iterator, and then you iterating through it was displaying all that stuff. But here, once you get the iterator, you have to display key value pairs. Key value pairs. In each iteration, it has to display a key and a value. So this is the change. You don't make a call directly to the iterator. You make a call to entry set and then to iterator. Whatever value it gets, here you have to specify the key here and the value here. And then this way you have to iterate through this iterator. And it's going to get you the key, left part, value, right part. It's going to display. But don't expect any specific order in which it's going to display the records. HashMap stores things using a technique known as hashing. And in hashing techniques, it doesn't maintain the order in which you store things. It's just that whenever you make a call to its remove function or get function, it does things so fast, because whenever you pass any object, JDK directly computes in which index it will store gone to. So you go to that index. If gone to is there, it means gone to is there. If you don't find gone to there, it means gone to is not there. You are not required to check the entire hash map to know whether gone to is present or not. You're just required to check a specific location to know whether gone to is there or not. Same way is for get. Yeah. So this is how it works. So now whenever you are going to do this, remove this, it's going to look for a key which matches with this gone to. It's going to find this, so it's going to remove this whole key value pair from here. When you are going to perform get, it's going to search for this key here. It's going to find here, and it's going to return you this object, line object. Now, same way, the way we have created an hash map for a string key and for a string object, we can create a hash map for a integer key and a string object, whatever we store against that key. See here, I'm storing integer key, and with that key I'm storing a string object. So here when I'm iterating through, it's going to give us key, all the keys and all the values, that too not in any specific order, as we saw in case of string keys. And then when we are removing, we have to just specify the key. Hey, we want to hey JDK, we want you to remove the key value pair which has a key 10 integer. So it's going to simply remove this whole key value pair from the hash map. When you perform this get, it's going to go and search for the key with value 5, and whatever you get, it's going to return you this string object. If you keep it in under system.out.println, it's going to print out this value. This is what it returns. The way you have used strings as a key, string object as a key, and then integer as a key, you can make use of country as a key, a user defined object as a key. Now what is the way to do that? Well, you store country object for the key. Alright, now when you are iterating through it, see, it's going to give you the country object, and then what you are going to print for the country, maybe population, or maybe you said this is going to give you the country object fully. After that, you want to print out population, you want to print out the name of that country, it's all your will. I'm here just printing population. And then the value, what's going to be the value? These are going to be the value. Again, no specific order, it's going to maintain. And when you want to remove any specific value, well, you are saying that please remove the value which is stored against this country object key. Now here also same thing is applicable what we looked at in case of HashSet. So this is going to remove this object only and only when you tell what is a strategy JDK has to follow to find out this element in the existing HashSet, right? So for that, what you did, you implemented equals method. And what equals method does, it gives you that strategy. It gives JDK the strategy which it has to make use of to understand how this object is, how the objects in HashSet have to be compared. Now same way, exactly same way here, the way equals method and HashCode method helps JDK to be able to compare this object with the existing objects in HashSet. Same way in HashMap, this is going to work only and only when you are going to implement equals and HashCode method. So equals method is what you need basically to tell JDK, hey, you have to compare this object with the existing objects. You have to compare this key with the existing keys based on this strategy. You have to compare only name or only population or both. So here we have already implemented equals method. We have here compared population and name both. So here it's going to compare name and population both to understand whether a specific key is matching or not. Okay, and an important point what you have to understand is when it's going to find out such an element, it's going to remove that complete key value pair. So it's going to find Nepal in 200 and it's going to remove the whole thing. Okay, so this is how it works. When you want to get the value which is stored against this key, well, again it's going to go to the equals method, and there it's going to check, it has to compare this key with the existing keys based on name and population both, because that's what we have written here. So whatever you are going to write here, according to that only it's going to compare the key with the existing keys. So Bangladesh in 10 is existing here, so it's going to get you the value what is stored against this key, and what is stored against this key, this is stored. So it's simply going to get you this string object. Hi, I am lying here. So if you keep this under system.out.println, it's going to print out that. So that's what is HashMap all about. The important point what you have to understand is in HashSet and in HashMap, you need equals method for it to compare things. And for equals method to work appropriately, you have to have this HashCode method, which, as I said earlier, I'm not going to explain you today. Once you are comfortable with everything what I've explained, then I'm going to explain the hashing techniques. In other words, this HashCode method. All right. Now, if you look at the output, HashMap. So this is the output. We have stored all these key value pairs and it has printed all these key value pairs when you use this iterator. Key value, key value, key value, key value. And then you removed and then you get. For that I'm not displaying anything. But if I use iterator after that, then it's going to simply not show the key value pair for this contour. It's not going to display this key value pair. And if I keep this maps.get, whatever, in the SOP system.out.println, then it's going to actually print out the value what is stored against this key. And what is stored against this key? This one, I am lion. Same is the case with integer key. So instead of this string value, you can store anything here. You can store an integer object, you can store a country object, you can store any user defined object. Whatever you want to store here against this key, you are allowed to store. That has to be an object. That's it. That's the only requirement. So here I showed you an example where I'm storing a string object with the keys. So I chose key as a string, I chose key as an integer, I chose key as a user defined object. You can choose anything as a key and anything as a value according to your project's requirement. The important point is, for user defined type, for this method to work and for this method work, for this to be able to find out a specific key, for specific key, you have to implement equals method in the user defined object. And for equals method to work properly, you have to also override HashCode method, which is nothing but the hashing technique, which I'm going to explain later on. So this is how HashMap works. HashSet allows you to store only keys. So here you are storing only keys. And HashMap allows you to store values against those keys. Okay, so that's all about the HashMap technique. Working of HashSet and HashMap exactly same. They work exactly in the same manner. The only difference is here you store values against each key. Here you store only keys in it. Cool. Now if you have any doubts, you got confused anywhere, you know what to do. Right after this session, you have to simply talk to me to understand how these things work. All right, let's proceed further, guys. Now let's talk about another important concept, linked HashSet. So far we talked about HashSet. So HashSet we understood fully, and we said it doesn't maintain the order. It does not maintain the order, right? This is what we said. Now linked HashSet is a Java collection which is exactly HashSet, except the point that maintains the order. That's it, nothing more than that. So linked HashSet is exactly HashSet. The only difference is it's going to maintain the order. Everything else apart from this circle is going to be the same, what you observed in case of the HashSet. The only difference is this. Instead of HashSet, you write linked HashSet. Okay. Now when it arranges things, it maintains the order. That's the only difference. It maintains, linked HashSet maintains the order, and HashSet doesn't maintain the order. Okay, let me show you its demo. Linked HashMap. Oh, sorry, linked HashSet. I'll copy and then we'll paste here. It's set, right? So let me paste it over here. Linked HashSet. Let me put it under its package, which is nothing but sets. Cool. Now if you see the way I used HashMap, the way I used HashSet, same way exactly I am making use of linked HashSet. The only difference is if I use here linked HashSet instead of HashSet, then it's simply when you are going to iterate through that, it's going to display things in the order. But if you use HashSet, it's not going to display things in the order. Rest everything is going to remain same, guys. Everything, not even a single difference. There not even the difference in the methods that you can use on a linked HashSet and linked or a HashSet. All right, so everything else is same, so there's nothing that I can explain here. Linked HashSet, this is how you create new object for that. You store all the keys in that. All right, string keys you are adding. Then when you use iterator, it's going to display things in the insertion order. The order in which you have inserted things is going to display things in the same order. When you are going to remove things, it's going to look for this key here, and then again it's going to use hashing technique to do the same, and it's going to give you the results instantaneously. So it's going to simply remove this element contour from here. And when you say contains, when you use contains method, you are simply asking whether this key is present or not in this or not. It's going to simply look for this key. If it is present, it's going to give you true, or it's going to give you false. Same thing I've done with the integers. I've created an integer object and then added integer objects to that, integer keys in it. Then I've iterated through that. When I'm going to iterate through that, it's going to maintain the order. So first it's going to print 1, then 20, then 50, then 110. When you're removing, it's going to search for this key. Well, if it's able to find out, it's going to delete that. If it's not able to find out, it's not going to remove that. When you make a call to its contains functions, it's going to search for this key. If it's going to find out, it's going to return true, otherwise it's going to return false. Point you have to understand is these two operations it's going to perform using hashing techniques. So very fast, no comparison with every element what is present in LinkedHashSet. It's only that when it sees this key, it's going to convert this key to an index value automatically by using some logic. So JDK simply goes to that index to find out whether that key is present there or not. If that is present, it means it is present. If it is not, it is not present, simply. Same cases with the user defined type like country. So here I'm using country user defined type. I'm storing all that in the LinkedHashSet of type country. If I'm going to iterate through, it's going to maintain the insertion order. So it's going to first display India, then America, then Nepal, then Bangladesh. And when I'm removing, it's going to remove, but point to understand the way HashSet works, same way LinkedHashSet works. So it's going to ask you for equals method, because using equals method, it's going to compare this key with the existing keys. And same is the case with contains method. When you are going to make use of contains method, it's going to simply use equals and HashCode method to understand whether this key is present in the existing LinkedHashSet or not. So if I run this, you will be able to understand this. See here, the order in which I have inserted Ankush, Gaurav, Gontu series, same order it has maintained. 1, 110, 20 and 50. So same order it has maintained. Insertion order 1, 110, 20 and 50. So it's not ascending order, it's not descending order. It's going to maintain the order in which I have inserted elements in the LinkedHashSet. 1, 110, 20 and 50. Same order it's going to maintain. And here also India, America, Nepal, Bangladesh. India, America, Nepal, Bangladesh. It has maintained the insertion order while displaying. Okay. So this is how LinkedHashSet works. Now the way LinkedHashSet works, same way there's one more thing, LinkedHashMap. LinkedHashMap is exactly the HashMap, no difference at all between LinkedHashMap and HashMap. Everything is same except the point that it maintains the order. If you use an iterator on a LinkedHashMap, then it's going to show you things in the order you use to insert elements in the LinkedHashMap. That's all. That's only. Everything else is what you have seen in case of HashMap. So everything is same. This part, this part, this part, this part. It uses hashing technique, uses HashCode equal method. So everything is same. Nothing special is there. So let's copy LinkedHashMap. This is LinkedHashMap. So let me copy here. So everything is same here. Only point is it's going to display things in the insertion order. That's it. So let me put it over here. Let me put it under its own package, maps. Required imports I have put. Now this is exactly the same. We used HashMap. Whatever we wrote in case of HashMap, same thing, same code I've written in case of LinkedHashMap. The only difference is instead of HashMap, I used LinkedHashMap. The only difference is when I'm going to use iterator over it, it's going to display key value pairs in the order I used to insert into the LinkedHashMap. First, it's going to display Ankush, hi I'm Apple, then Gaurav, hi I'm Orange, gone to, then I am banana series, I am line. That's how it's going to display. This is a key, this is a value. This is how it's going to work. Let me show you this running. See, Ankush, I am apple, Gaurav, I am orange. So same insertion order it has maintained. Same thing I've done for integers key, what I used for LinkedHashMap. So it's going to maintain the order. See, 220, 10 and 220, 10 and 5, same order. And then LinkedHashMap, same order. India, America, Nepal, Bangladesh. See here, with every key I'm displaying population. So it's displaying 20, which is here, and then displaying 1000, which is here, then displaying 200, which is there, and then displaying 10, which is there. So LinkedHashMap is exactly same the way a hash map works. The only difference is if you use an iterator on the LinkedHashMap, it's going to display results in the order which you use to insert elements, and that's all about it. Nothing more than that. So we have looked at all the points so far. Let me revise things very quickly for you. So we looked at HashSet, we looked at LinkedHashSet, we looked at HashMap, we looked at LinkedHashMap. The only thing which is remaining is TreeSet and TreeMap. Now what are these things? Let's see TreeSet and TreeMap also very quickly, and that's all about it, guys, for today. Okay, what is a TreeSet? Set is something which is not going to allow you to duplicate elements in that. The only benefit with TreeSet is whenever you add things in it, like 20, 10, 40, 60, 1, 5, after that if you are going to add say 10, it's not going to allow you doing that. It's going to override this existing with that new one. Okay, so no duplicate values are allowed in TreeSet. That's a property of TreeSet Java collection. And the important point what you have to understand is why you have to use TreeSet, because it's going to arrange things, it's going to give you things in the ascending order. So if you use HashSet or LinkedHashSet, it's not going to give you results in the ascending order. If your requirement is that you have to use ascending order, you know, if you have to whatever unique items you have stored in the set, if you have a requirement that you want to get all those in the ascending order, then you have to use TreeSet. Now the difference between TreeSet and HashSet or LinkedHashSet is HashSet or LinkedHashSet uses hashing to store things. Well, TreeSet doesn't use hashing. TreeSet doesn't use hashing means TreeSet doesn't use HashCode or equal method to compare objects. It stores things in the ascending order by comparing objects in it, but for that it relies on comparable and comparator, its interface itself. Okay, the way we looked at for array list, linked list, same way TreeSet also works. The only difference is array list, linked list, vector stack, all these are basically, you know, lists. Okay, and TreeSet is something which works on a principle known as binary search tree using something called as red-black algorithm. Internally it works using a technique binary search tree red-black algorithm. For now it's enough for you to know that it works behind the scenes using this way, but you can always know about these things later on. Okay, so once you are comfortable with everything what we have learned in Java collections and you are doing great, I guess at that time I would be able to talk about what is this binary search tree and red-black algorithm which is used, you know, behind the scenes for a tree set. What you have to understand is if your requirement is to store unique elements, unique items in the Java collection, and when you want to retrieve things, your requirement is to retrieve things in the ascending order, then you have to use TreeSet. And when you use TreeSet, you have to understand that country object has to implement comparable interface, or If it is not implementing comparable interface, then you have to use comparator objects like name comparator or population comparator. So that's how this works. The way TreeSet works, guys, same way TreeMap also works. The only difference is with every key that's you are going to store value against that. Everything else is going to remain same, what you are learning here in case of TreeSet. So let me show you the demo very quickly for the same. Alright, so here's the demo for TreeSet. Let me copy it, show you here. Let us keep it under this category, TreeSet. Let's change its package sets. Now let's try to understand it. This is the way how you can create a tree set for string type. You are storing all the objects using its add methods, then you are iterating through it. When you are iterating through it, it's guaranteed that it's going to give you results in the ascending order. So first it's going to print Ankush, then Gontu, then Gaurav, and then series. So it's going to arrange things in the way dictionaries are arranged. So it's called as dictionary order or lexicological order. Okay. And if you are going to remove things, remove any key from here, it's going to allow you. Okay. Now there's something called as floor that you can get in a tree set. What is a floor? Let me explain you. So because tree set is going to arrange things in the ascending order. So if you are going to keep 20, 10, 40, 60 and so on here, it's going to arrange things in the ascending order. So it's going to arrange it like this: 1, 5, 10, 20, 40 and 60. Now when you say, hey, please give me floor for an element 20, what it's going to give you? It's going to give you the nearest element to that, which is immediate lesser than that number what you are searching for. That's what it's going to give you. So when you say, hey, give me floor of 20, it's going to give you the number which is behind that number, which is here 10, right? So it's going to give you result as 10. And there's something called as ceiling. So if you seal, so if you want a seal for a number 20, what it's going to give you? It's going to give you immediate next number of 20, 40, because it has arranged things in the ascending order. So it can give you floor, it can give you seal also of any number, right? Immediate lesser number, immediate greater number. That's what is floor and seal all about, and that's what I have computed here. You can compute floor by specifying the key. So here you are telling, hey, give me the floor for Gontu. And what is floor for Gontu? What is floor for Gontu? So the key which is immediately lesser than that, immediate lesser than that, and that is nothing but Ankush. So that's what it's going to print if you are going to use this using system.out.println. If you are making use of sealing, so what that means? Immediate next key. What is next key of this Gontu? Next key is Gaurav. So it's going to print out this. If you are going to print this out, if you are going to print this using system.out.println, and then you are using strings.first, strings.last. So when you are making call to first function, it's going to give you the first element, which is here in the ascending order. Ankush is going to come as first, right? So it's going to display that. When you are calling its last, it's going to get you the last element, whatever comes when it's going to arrange things in the ascending order. Last comes as series. Okay, so it's going to display that. Now same thing is applicable for this integer keys. Tree set with the integer. I'm storing all the integers, then I'm iterating. It's going to display things in the ascending order. Then I'm removing this key. It's going to remove this. I'm getting the floor of 20. What is the floor of 20? Well, immediate lesser value of 20 is what? It's not 110, it's not 50, it's 1. So it's going to give you the result 1. But here we have removed that 1 already before this statement. So 1 is not there. So which is the floor value of 20? Well, it's null, because there is no value. It means it's going to return you null. Okay. And ceiling of 20 is what? 50. That's what it's going to print. First value here is going to be what? Because 1 is already removed, so what is there at first position? 50, and at last position 110. That's what it's going to return. Alright, so that was all about a tree set using an integer key. And here let me talk about a tree set using a user defined key like a country. So here I'm adding all country keys to it, iterating through it. It's going to give things in the ascending order. Now the point that you have to understand is, for it to arrange things in the ascending order here, it is mandatory that the country either uses the comparator the way I've used here, or if it's not using comparator, then this country should have the comparable interface, because using either comparable or comparator only it's going to allow you to get the results. Okay, so either use comparator, appropriate comparator like population or name, or it's mandatory that country has to implement comparable using its compare to method, or comparables compare to method, or comparators compare method. It's going to know if an object is bigger, smaller, or equal to than other object, and depending upon that it's going to arrange things in the ascending order. Alright, now because here I'm using population comparator, so it's going to arrange all these country objects based on the population. So first going to come, America will come, second India is going to come, and then Nepal is going to come, and then Bangladesh is going to come. That's how it works. When you are removing, again, to remove this object, to remove this key from here, it is going to need that compare to method or compare method of it. So here we are making use of comparator, so it's going to compare only population part of it with the existing keys. So it's going to find out this 10 here, so it's going to remove this. It doesn't matter whether here you have written India or America or whatever, any country's name you can write over here, but because you are using population comparator and it's going to compare things using its compare method, so if it's going to find out 10, it's simply going to remove that. When you are using floor, it's going to give you lesser value, immediate lesser value of this key. And what is immediate lesser value of this 1000? Because we are using population comparator. So what is less than 1000? It's 10. So it's going to give you India here. If you are printing this under SOP system.out.println, it's going to give you India. And if you are going to ask it to get you the ceiling for the same, it's going to give you immediate next key, which is nothing but Bangladesh, right? Because 2000 comes after 1000 and there's nothing in between. First is going to get you the first element. And what is the first element? Well, because we have used removed here, India, value 10. So first element is going to be what? India 10 is removed. So if we call first, it's going to print out this one, because that's how things it's going to arrange. And if you call last, it's going to display Bangladesh. Make sense? So that's how it works. But wait a moment, I here computed floor for Nepal 1000. What I computed, that floor for Nepal is going to be what value? Floor means immediate lesser value. Immediate lesser value is 10, but because we have already removed India 10, so that's not going to be present there. So immediate lesser value of Nepal is definitely going to be 1 here. Okay, so that's what it's going to print. And successor value means immediate next value for Nepal is going to be Bangladesh, which is this value. Right, so this is all about TreeSet. The way we have learned TreeSet, same way TreeMap works. It is exactly same like TreeSet, except that in TreeSet we store only keys, and here with every key we are going to store a value. That's it. Everything else is going to remain same. It's TreeMap. Okay, It's going to maintain ascending all the keys in the ascending order. It is not going to allow you duplicate keys. It's keys. All right. And you can make use of comparable or comparator interface the way you used in case of the TreeSet. So let me very quickly show you the demo for the same, guys. What you have to understand is TreeSet and TreeMap both works on the principal binary search tree using red-black algorithm, which I talked about here, which I'm going to explain you later once you are comfortable with everything. All right. So you have to ask me, Ankush, what is binary search tree and what is the red-black algorithm? I'll be more than happy to make you understand all that. The only requirement for you to understand all that, once you have practiced all that what we have learned so far in Java collections, after you practice all that, you will be able to understand binary search tree and red-black algorithm also very easily. Okay. All right. So let me show you TreeMap. As I said, TreeMap is exactly the TreeSet. The only difference is with every key you are going to store value. So in TreeSet you are storing only keys, and in TreeMap you are going to store values also. But this is going to come under category maps. Well guys, no more collection. So this is the last collection we are learning. So just be happy that that's all about it. Nothing more. Okay. All right. So in case of TreeSet, we stored only keys, and in case of TreeMap, we store key and the value against that. So here I'm using string as a key and string as a value. I'm putting key value pairs in it. I'm iterating through it. It's going to arrange things in the ascending order. Well, it's going to first give me Ankush its value, and then Gontu its value, and then Gaurav its value, and then series its value. Lexicological order, dictionary order wise. Okay. Again, same thing. To remove this key, it's going to simply go and remove the whole key value pair. Floor key. Floor key means this is the key that you are searching for, and you want it to retrieve, its floor. Returns the greatest key less than or equal to. So what it's going to do, this line is going to return you the key which is lesser than this key. So what is lesser than this key? Gaurav. So it's going to return you this key, Gaurav. Ceiling key, when you are finding for this key, it's going to give you immediate greater key than this, which is nothing but for this Gontu, if you are talking about floor key, it's going to so basically floor key means you are trying to get immediate lesser value of Gontu. And what is lesser value of Gontu? It's not Gaurav, it's Ankush, right? And immediate greater value of Gontu is Gaurav, right? R comes after N, so in dictionary. So if you print this, it's going to give you the key Gaurav. If you print this, it's going to give you the key Ankush. But wait a moment, because we have used remove here. So it has removed Ankush key value pair, right? And after that, we are talking about floor and ceiling. So what is the value for this Gontu floor? Well, there's nothing behind this. It's the first value. So it's going to display null here if you display it using SOP. And if you display ceiling of Gontu, it's going to display Gaurav. Yeah. First key here is going to be Gontu in these three, because Ankush we have removed. Last key is going to be series. Make sense? Same thing we have done in case of the TreeMap, where I've used key integer as a key and string as a value for that. I've stored all the integers. When I'm going to iterate through it, it's going to display key value pairs in the ascending order. 1, then 5, then 20, and then 200. Then it's going to remove this key value pair. It's going to give you the key which is less than 5, which is 1. It's going to give you. When you search for ceiling of 5, it's going to give you what? It's going to give you 20, but because 20 we have already removed. So what is next after 20? It's 200. So ceiling of 5 is 200 here. Okay. First key after we have removed 20, first key is definitely going to be 1. last key is definitely going to be 200. Okay, so that's how it works. TreeMap for country object, user defined object. So here I'm using key as country, user defined type, and value as string. I'm storing all key value pairs, iterating through it. Now when it's going to arrange things in the ascending order, it's going to make use of either the comparable interface, which is implemented in this country object, which is here in this case it's actually using comparable interface. But if I use here any comparator instead of it, say population, then in that case it's going to make use of that comparator. It's compare function it's going to use to arrange things in the ascending order. Because I'm not doing that, it's going to use its compare to method, where we have used if you remember, I'm using population, right? Only population as a criteria. So what it's going to do, it's going to arrange things based on the population. So first it's going to display this key value pair, then this key value pair, and then this key value pair, and then this key value pair. When I'm removing, it's going to remove by making use of its compare function, compare to function of this comparative, of this comparable interface, right? So it's going to remove 10. If I'm talking about floor key for this object, Nepal 1000, so what is the lesser value of 1000, which is nothing but 10, right? Which we have removed here, right? So lesser value is going to be America 1 here. And what's going to be ceiling for 1000? Next value of 1000 is 2000. And first key is nothing but America, and last key is nothing but 2000. That's all about it, guys. That's what is a tree map. The difference between TreeSet and a tree map is, in TreeSet we store only keys, in TreeMap we store values against those keys. Now these values I've used as only string. You can store string, integer, anything as a value, or a country object, anything that you want to store as a value as per your project's requirement. Guys, this topic is very simple. The only thing what you require is not to remember things by saying, oh, what does TreeSet does, oh, it uses comparator or equals method, what it does. You don't need to remember things like this. What you need to do is you need to just practice, and that's it. Don't try to remember things artificial way. Try to remember things with practice, and that way you will be able to understand every bit of it clearly. Okay, now we have talked about array list, linked list, vector, and stack. That's what I kept in one here. And then we talked about maps, where I showed HashMap, HashMap, LinkedHashMap, and TreeMap. See here, HashMap, LinkedHashMap, and TreeMap. Okay, these are the three things. And then I showed queues, array dequeue, priority dequeue, array dequeue, priority dequeue. Then I showed sets, HashSet, LinkedHashSet, TreeSet, which is nothing but this HashSet, LinkedHashSet, and TreeSet. So these are the Java classes that we learned, guys, overall. Alright, so these are the overall classes what we learned in Java collections. Now the point that you have to understand, well, I'm just explaining you this whole diagram. I'm going to explain you this diagram fully once you are able to practice Java collections fully, because it's only after that you will be able to understand the significance of this diagram what I'm showing you right now. But before that, let me talk a little about this diagram. So here these are classes. In this color whatever I've written, these are basically classes, and in this color what I've written, these are basically interfaces. Alright, so this is interface, all of these boxes with this color are basically interfaces. So interfaces you basically implement, right? That's what you do. You write class implements an interface. That's what you do, right? You remember that manager developer story that I talked about when I explained you interface? So an interface is always implemented by the classes. So array list implements list, linked list implements this, so likewise all. So this is how this whole hierarchy works. This dotted line means what? This dotted line means implements. Because a class can only implement an interface. So that's what is this dotted line. And wherever you're seeing this full line which is not dotted, it means extends. List interface is extending collection interface, which is possible. Collection interface is extending iterable interface, which is possible. Queue interface is extending collection. DQ interface is extending queue. Array DQ is implementing DQ. Alright. Same way. HashMap is implementing. HashMap is extending. HashMap is implementing abstract map. Abstract map is implementing map, which is basically an interface. All right, so this is also a class, abstract map. Yeah, an abstract class. All right, so this is the interface and this is the abstract class. Now why I'm showing you this whole diagram, the point that I want you to understand is this is the hierarchy what Java people have maintained for all Java collection, for all collection classes, array list, linked list. So array list is always implementing linked list. Array list is a class which implements the list interface, and list interface is an interface which extends collection. Collection extends iterable. So you can look at this whole hierarchy. HashMap implements abstract map class. Okay, this is an abstract class. Now this abstract map class implements this map interface. So this whole hierarchy you can understand. Dotted means implements and full line without dots means extends. Now what is the significance of this whole diagram? Why I'm showing you which class is extending, which class is implementing which interface? The reason you will understand once you are able to practice this whole Java collection. So practice and then you'll be able to understand all that. What is next? Guys, it's time to go for assignments. Go and practice. Check out what's in your assignment. Practice, and that's all about it. Thanks for being so patient while learning Java collections. It's the most difficult things to digest, but at the same time easy one. You just need patience to learn these things. That's all about it. And then you need patience when you are practicing this. That's all about it. Okay, so let's catch you guys in the one-on-one conversation. Please go and have a break of 5, 10 or 15 minutes as per your schedule. Come for one-on-one conversation with me, and I'm gonna make sure that you're gonna rock with Java collection. This is what I say, and I mean it what I'm saying. All right, thanks for joining me. Have a wonderful day.